Hey everybody, today I'm going to do some percent yield practice problems with you guys and go over some of the things you need to know about doing percent yield. Okay, so after your mind class you have this assignment, percent yield practice problems. You got to make sure that you show your work per usual in order to receive all the credit on these, okay? So what I want to do is I'll go through number one, which kind of breaks down how to do these problems, and then do another random problem just as an example. If you were in class, then you saw number one worked already, so you can fast forward to the other one if you want. But if you missed it, or if you want to go through the slower version again, you can watch that one again, okay? So number one says, what is the percent yield of NH3 if 40.5 grams of NH3 is produced from 20.0 grams of H2 and excess N2? So there's a couple steps to solving a percent yield problem. All right, a percent yield problem is just where you calculate at the end of a conversion problem how much you got versus what you should have gotten. Okay, so for any percent yield problem, you're going to need a balanced chemical equation. Sometimes it'll be given to you, sometimes it won't. If it is given to you, make sure it's balanced. If it's not, then you're going to have to write it out and balance it. Okay, so make sure you have one. So in this case, it does not give it to one, so we have to write the balanced chemical equation. So we got to see what chemicals are being made in here. Here it says 40.5 grams NH3 is produced. So I know that NH3 is getting made in this chemical reaction. So I know for a fact that it is making NH3. Okay? And then it says from 20 grams of H2 and excess N2. So I know I got hydrogen and nitrogen are creating ammonia in this reaction. Okay, so H2 plus N2 results in NH3. Alright, so there's the chemicals, there's the equation, and just need to balance it now. If you look at the N, I got 2 here, so I need a 2 in front of this to get 2 nitrogens. That's going to give me 6 hydrogens, so I'm going to need a 3 over here to get 3 times 2 is 6 hydrogens on the left. So 3, 1, 2 are my coefficients for this chemical reaction. Alright, that wasn't too bad. Step 2, determine actual and theoretical yield. Look at these words. The actual yield is given to you. The actual yield should always be given to you in a word problem. So I got to look back up at the problem and see I've got two numbers, 40.5 grams or 20 grams of H2. One of those is my actual yield. So in a percent yield, you're calculating what you've made. Generally, what you've made is going to be your product. All right, so if you've got two products, then you have to figure out which one of those is the thing that you're yielding. Also look for keywords like produced, makes, creates, synthesizes, gives us, stuff like that. In this one it says 40.5 grams of NH3 is produced. So that's my actual yield because that's the thing that is getting made in the reaction, and that's how much they actually got. Okay, so my actual yield equals 40.5 grams of NH3. Okay, so I have an actual yield. Now I have to calculate my theoretical yield. The theoretical yield is how much you should get if you react a certain amount of one of the reactants. So in this case, I've got 20 grams of H2. That's what I'm starting with when I calculate how much NH3 20 grams of H2 will make. If you look at your stoichiometry roadmap, this means that I'm going through a grams to grams calculation. I'm going to take the grams of H2 that I start with and convert it and figure out how many grams of NH3 that I'll end up with. Your theoretical yield has to be in the same units as your actual yield. So this theoretical yield that I'm about to calculate I don't know what it is yet, but I do know that it should be in grams of NH3 at the end to compare between what I actually got and what I should have gotten. In order to compare, they have to be the same units to get a percent yield. Okay? So, take the other number that you receive, which was 20 grams of H2, and we're going to start with that, and we're going to convert it from grams of H2 into grams of NH3. Alright, so like all the conversion problems we've done so far, you always start these off the exact same. You start by writing down what you're given. 20 grams of H2. All right. Next step, multiply by a fraction. So we're going to create a conversion factor on that fraction. Next step, whatever units you have here, those are the units that need to go on the bottom of that fraction because you want them to cancel each other out. So I know I'm going to go to grams of H2 right here. Now I can't go straight from grams of H2 to grams of NH3. You can only change from grams of a certain chemical to moles of that same chemical. So I'm going to go from grams of H2 to moles of H2. Right? And I know from the previous unit that 1 mole of H2 is always equal to the molar mass of H2. And the molar mass of H2, if you look at the periodic table, 1H is 1.008. So 2 H's is 2.016 grams. Okay? This will give me a number in moles of H2. So I keep going, do another conversion factor until I get to the correct unit that I want, which is grams of NH3. So this top unit, you bring it down, moles of H2. I'm trying to get to grams of NH3. I can't go straight from moles of H2 to grams of NH3 because those are two different chemicals, so I have to go to moles of NH3 first. Now the numbers that go here are the mole to mole ratio that you have in the coefficients of your equation. Okay, because this equation relates these chemicals to each other in this reaction. So NH3, there's 2 moles of NH3 made in this reaction for every 3 moles of hydrogen that get used. So the ratio of moles of NH3 to moles of hydrogen is 2 to 3. This will give me moles of NH3. So I got to keep going until I get grams of NH3. So moles of NH3 comes down. And I can change moles of NH3 to grams of NH3 using the molar mass of NH3, because 1 mole of NH3 is going to be equal to the molar mass of N and 3 H's. So if you add up N and 3 H's, you get 17.031 grams. Okay, so let me double check my units. Grams of H2 on the bottom, so those guys will cancel out. Moles of H2, so those guys will cancel out. Moles of NH3, those guys will cancel out. So the units I'll be left with are grams of NH3, and that's what I want. Okay, so the math in this is going to be 20 divided by 2.016 times 2 divided by 3 times 17.031. So, calculator. 20 divided by 2.016 times 2 divided by 3 times 17.031. Enter. Alright, that gives me 112.63888888. For stoichiometry problems, you always have to have your answers in significant figures. So in this case, you got to look at the numbers other than the mole-to-mole ratio. Those are always 1, so we don't use those as sig figs. I actually wrote this down wrong. This should have been 20.0 is what it gave us on the worksheet. So 3 sig figs there, 4 sig figs there, 5 sig figs there. So 3 sig figs is what my answer should be. And so 112.6 is going to round up to 113 grams NH3. Okay, be careful when you're taking a test, because some people might be like, oh, we're done, 113 is the answer, and I'll bet you that would be an answer choice. But remember, the original problem asked us to calculate the percent yield. So now we got to calculate the percent yield of this reaction that we just did. The percent yield is always equal to the actual divided by the theoretical times 100. Okay, so we're just going to take the actual that we were given in the problem, which is 40.5 grams of NH3, and divide that by what we should have gotten when we reacted 20 grams of H2. We should have gotten, theoretically, 113 grams. We'll multiply that by 100 to get a percentage. Okay, so we'll calculate all. Clear that guy. 40.5 divided by 113 equals times 100. 35.8407. We'll have 3 and 3, so the answer should be 3 sig figs. So 35.8% yield from this problem. Okay, notice there's no units for percent yield because the grams of NH3 and the grams of NH3 are going to cancel each other out. So there's no units, just a percentage. So 35.8%. So this is actually not a very good reaction. 35% yield is not very much of a product. So remember, your theoretical yield is usually higher. Theoretical yield is usually higher than the actual yield. In fact, it should always be higher because you're never going to get a perfect reaction. You're never going to get exactly what you should have gotten. Alright, so that's how you solve for theoretical yield. Let me do another one just so you have more than one example. I'll go through this one just a little bit faster instead of walking through all of the steps. Let's do number 3. It says, according to the following equation, calculate the percent yield if 550 grams of toluene is added to an excess of nitric acid, and this provides 305 grams of the p-nitrotoluene product. So here's my keyword, provides 305 grams of p-nitrotoluene. So this is my actual yield because it's telling me I get that. There's only 2 products and one of them is water. So I'm going to bet that this one is the p-nitrotoluene product. So my actual yield for this problem is 305 grams of C7H7NO2. That's my actual yield. So now I need to calculate my theoretical yield. My theoretical, I don't know what it is yet, but I know it's going to be in grams of C7H7NO2 because I have to get it in the same units as that to compare. All right. So the reactant that we're starting with on this one is 550 grams of toluene, which is C7H8. So we're going to start with 550 grams of toluene, C7H8. So 550 grams C7H8. That's what we're starting with. So once again, I'm doing, if I look at my roadmap, I'm going to do a grams to grams conversion. This time I'm going from the toluene to the nitrotoluene. Okay? So notice this is another grams to grams conversion, so I know I'm going to have exactly the same number of steps as I did before. I'm going to convert from grams to moles, then use the mole to mole ratio to figure out how many moles I have, and then do a moles to grams to figure out the grams of the product. Alright, so grams C7H8 here for every 1 mole. C7H8 will go here, so the grams will cancel. So moles of C7H8 here. And for sake of space, I'm not going to write all of this guy down here. Moles of my product here. Moles C7H7NO2, my product, for every how many grams of C7H7NO2 here. Alright, so now I'm just going to go in and fill the numbers. There's 1 mole, and I pre-calculated the molar masses for these big compounds, okay, by just adding up their masses from the periodic table. So the molar mass of toluene is 92.141 grams, and then the molar mass of nitrotoluene is 137.138 grams. 137.138 grams. That's how many grams there are per 1 mole of nitrotoluene. That's how many grams there are in 1 mole of C7H8. And then we go back to the actual assignment to look at the balanced chemical equation, which is balanced with 1s all the way across, so this is actually just a 1-to-1 ratio, so there won't be any math right there. So now we're going to double check, make sure our units cancel out again. Gram C7H8, gram C7H8 will cancel. Mole C7H8, mole C7H8 will cancel. Moles of the product, I didn't want to write it, moles of it will cancel, and we'll end up with grams of the product, which is what we want. Okay, so let's find out what that equals. So the math here that we're doing is 550 divided by 92.141, nothing there, times 137.138. Okay, so clear. 550 times 90, times 137.138, doing them out of order, but it really doesn't matter, divided by 92.141. Okay, woo, big number. 818, and let's see, sig fig wise, I had 55.0 actually. This is 550.0. So that's 4 significant figures. And these guys have more. So my answer should be 4 significant figures. So this is going to be 818.59. And so the 9 will round the 5 up to 6. So 818.6 grams of C7H7. That's a 7, I promise. NO2. So my theoretical yield is 818.6. Once again, don't forget, it's not the end. The percent yield is your actual divided by your theoretical. So 305 is what we actually got, divided by 818.6, and times 100 for a percentage. We can already tell it's not going to be an amazing yield. 305 divided by 818.6, and then times 100 for percentage is 37 point, this has 3 sig figs, this has 4, so my answer is 3. 37.3% is my final answer. Okay? Alright guys, I hope that helps you out. If you have any additional questions, you can either email me or you can message me online. See you in class.